We're going on now to the last section we cover in Math 100, Section 6 of Chapter 5, dealing with perfect square trinomials and the difference of perfect squares. In review of an earlier section, we said that these up here were special products. That is, if we were squaring a binomial, we would square this term, multiply these two terms together, then double it, then square this term. This produced a perfect square trinomial right there. And then we said if we had the sum and differences of the same terms, and we were multiplying them through FOIL, the middle terms canceled out, and we ended up with the difference of perfect squares. Okay? And another name for these factors here, we said they were conjugates of each other, where one has a plus sign, the other has a minus sign, but the terms are the same. And whenever we multiply conjugates, we end up with the difference of perfect squares, and the middle terms cancel out. Now, later in your math sections in 105, you're going to use this a lot too. Okay, so we'll move it up, we'll pause it, and let you take a look at the vocabulary. So, going over these then, an expression that does not contain any factors that can be factored further is factored completely. The expression x squared minus 36 is an example of the difference of perfect squares. Difference by the negative sign. This expression, x squared minus 12x plus 36, is an example of a perfect square trinomial, and it came from squaring this binomial. Now, how did I do that? Well, I said this was our first term. I took half of this, and I got that. And if you worked it the other way, square that, you get this. Multiply these together, double it, you get that. Square this, you get that. That is a perfect square trinomial. And if we recognize that, it will factor into this, a binomial squared. Now, if we have a binomial squared in an equation, all we're going to do is take this 2, bring it to the other side as a negative 2, and divide by 3, and we get a root that, since it's going to occur twice, because it's the same, we call that a repeat root. Okay, so a little something as we go into the individual problems. Now, in example 5, they're asking us, is this a perfect square trinomial? Well, the test of it is, well, this is a perfect square, and this is a perfect square, so that part it meets. But what's the square root of 81? The square root of 81 is 9. If we double the 9, we get an 18. So, no, this is not a perfect square trinomial. Now, if this were a negative 18 there, then yes, it would be. But with the 9 there, no. All right, now they want us to factor this completely, and we must remember the rules we had. Put it in standard form. Y squared plus 8y plus 16. Now, I recall on one of your tests, that was the case, and the students, they just get all messed up. They forgot to put it in standard form. And is this a perfect square trinomial? Well, take the square root of 16, 4, double it, you get 8. So the answer is yes. So if you recognize it, you can just put it like this and don't have to write the 2 parentheses. But that's another way to go too. So this will be y. And in a sense, you can take half of the 8 and that sign, and then check it through that special process. And it does check. Now in number 7, you're looking to see that, is there a common factor? Yes, we can't forget that. So we put the 2 out there. Then it becomes a squared plus 6a plus 9. Now this is a perfect square trinomial. Take the square root of a squared, gives us a. We're going to use that middle sign. What is half of 6? Is 3. And don't forget to put the quantity squared. Then check it. Square this, multiply these, double it, square that. Yep, this checks too. I want to show you strategy. So we'll look at this and say, what do we do? Well, we could factor it this way, or we could rewrite it the other way. So that's what I choose to do. And half of 10 is 5, and 5 squared is 25. So this is a perfect square trinomial. Now, don't forget, we use that middle sign. And check it, and it checks out. This one's a little different. But half of that is 2, and 2 squared is that. Yes. So that is a perfect square trinomial. Going to use that middle sign. And half of that we said was 2. And the square root of that is this. So square this, get that. Multiply this together. We get a 2xy, double it, 4xy. Square this, we get 4x squared. This checks too. Now here there's a common factor. So I'm going to put it in standard form first. Now it's in descending power standard form. I'm going to factor out an x. Now I see this is a perfect square trinomial. I take half of the 20, gives me 10, square that, yep. Use that middle sign, take half of that. Don't forget to put the square there. And this checks out. Now, if you're watching the other set of videos I prepared, I noticed on this one there's a little error here. I had put a square there, which was incorrect. Remember, if you spot an incorrect presentation somewhere, a little error that I make, I give you a bonus point. Kind of record the time down at the bottom of the screen here and say, oh, you had that. And I'm happy to give them out. Sometimes I might do it on purpose. You never know. To give you folks a little motive to more closely watch the videos. Now here's one that's just a little bit tedious. Look at that. Well, again, if you square this, 1 times 1, you need 2 decimal points, and you get this, and you square the c. And half of this is 0.5. So actually it's not too bad, but you had to watch the decimals here. All right, moving right on now to example 12. Is this the difference of perfect squares? Well, that's a perfect square, and 1 is a perfect square, and there's a different sign. So yes. Now, when we see perfect squares, whatever form they're in, remember we can factor them into their conjugates. So let's put our 2 sets of parentheses up here, because that was the difference of perfect squares. They didn't give you too many easy ones right away. These are more challenging. So you can just do it this way. Put a 3 there and a 3 there, and 1 will be a plus and 1 will be a minus. And that's just going to be M, N, M, N. And then if you FOIL it, you see you get what we have. Now again, look at it. Is there a common factor? Yes. So we'll factor out the 5. Actually, it's 5a we're going to factor out. And we get then b squared minus 4. So we put the 5a and then 2 sets of parentheses for our conjugates. b plus 2, b minus 2. Once you recognize you have the difference of perfect squares, factor it into its conjugates. Now notice here you can factor out the 15, and you get x to the 4th minus y to the 4th. Now those are the difference of perfect squares, which will factor into, kind of ran out of room, so this will be x squared plus y squared minus y squared. Now if you left it like this, that would be maybe partial credit, but if you put this into MATLAB, they're going to count it wrong. Why? Because this can still be factored. This one over here can be factored into y. Let's put the x first, though. X plus y, x minus y. So it would be this, 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 and the 15 out in front would be your final answer for this. So these are getting a little challenging, and you just follow a pattern, and you just need to be careful about that. All right, number 16 is a little bit tricky. Again, look at it carefully. There's a y squared, there's a y to the 6, so you can factor out, I should say, an x squared out of both of these. And then you get this. So you need your x squared out there. Square root of that is 8. Square root of that is y to the 4th. Plus, square root of that is 5. Square root of that is x to the 2nd. And one of the things I should have mentioned, if you have the negative sign here and the positive sign there, that's okay. I prefer to put the positive and then the minus. But That's a matter of preference. I've seen it both ways. All right, let's go on. Now, I could write some of these out, but again, I'm interested in having you go through the theory with me a little bit. So here's a perfect square. This is a perfect square, but the sign in the middle is plus. This is the sum of perfect squares. And this doesn't factor. So this is prime. It's only the difference of perfect squares. Now here, this is a binomial that's squared. So in a sense, that is a square. There's a negative sign, and that's a perfect square. So this is a little modification, little higher math here. So it's going to factor into its conjugates, but the conjugates spread out a little bit. So we're going to put here y minus z. Let's make a z out of that. Plus 8. And then this same thing, y minus z minus 8. And believe it or not, that's the answer. Again, it's a little tricky, but it's sort of like a, think of this as a, that's a, and then plus 8 minus 8, and a is y minus z. Now, in number 19, as I look at that, let's see if we can figure something out. Now, as I looked at this, I saw there were 4 terms there. Well, what method did we have in the past when we had 4 terms? Factor by grouping. So out of these two, I factored out the x squared. Out of the last two, I factored out a negative 9. Then I put it into this form. But then I noticed here, this could still be factored. And there's our answer. Now, this one, before we go on, I'll pause it to do it, but notice if you put a parenthesis right there, I don't know if you noticed, but this is a perfect square trinomial that will factor into p plus 5q, the quantity squared, minus 100t squared. So that's kind of tough to figure out, because you might have said, well, do I factor it by grouping? Well, no, because in this case, this is a perfect square trinomial. Put your parentheses. So this will now factor into, again now, this is the difference of perfect squares. So we just write this there, and then it's going to be a plus 10t right there, and a minus 10t. So some of these are more challenging than what you normally expect in this course, but again, this is a college algebra course, and they're preparing you for the 105. And then in 105, you get some quite challenging items. All right, there was lots of writing here, so I tried to keep the tape down to a reasonable size. Looking at 21, and here they want us to solve because these are equations. Well, I want to put this in standard form, so I'm going to transpose the 12. And now I have a perfect square trinomial that will factor into this. And now I have 2 of these factors that equal 0. So they're both going to be the same answer. So I transpose the 6, it becomes a positive 6. And I have x equals 6. Now this is a repeat root, so I only have to write it once. Notice it is an equation to the second degree, so I needed two roots, two solutions, but since the solutions are the same, I only write it once. And again, I transpose that, I get this. This is the difference of perfect squares. I transpose that, and I now get here for this one, x is equal to a negative 1/7, and here x is equal to a positive 1/7. And this was already as a difference of perfect squares equals 0, so I factored it into its conjugates. And here this will be x equals, when I transpose it, a negative 8. This is going to be x equals a positive 8. Now this one was a little tricky. All I had to do was, though, is move this over to the other side. I now get 4 terms. This wasn't a perfect square trinomial, but I could factor by grouping, which was what I did. I got this out of there. I reversed my signs, got this out. Combine this into that, times this. But this now is the difference of perfect squares, which I factored. So here, this is going to be a negative 2. This will be a positive 2. And this will be a negative 3. So there are my 3 answers, because this equation is to the 3rd degree. I would need 3 answers. Now remember, I said this was to the 2nd degree, but because the answers were the same, I only had to write it once. Almost finished. Now for 25, this doesn't factor. And in order to get an answer, you'd have to use a calculator, which we're not using. And this one gives you a wild decimal answer, so we're not going to do that one either. So let's go on to our last few, where they want us to find zeros. So again, instead of f of x, we're going to put a 0 there. And let's see what happens. So as we go to find the zeros, we put a 0 there. I'm just writing it this way. This is a perfect square trinomial that will factor into this. And I only have to write it once. I just transpose the 1, and we get here x equals 1. Now, x equals 1 is 2 answers. When it's repeated, we only write it once. And here we have to factor out the 5. And we get a perfect square trinomial. Now, you might say, well, what happens to the 5? Well, we just divide both sides by 5. And these 5s just cancel out. So we end up with this. And that's a perfect square trinomial that becomes this when we factor it. So here, x equals 3. It happens twice. We only use it once. And here we factor out the 4. Again, the 4's divide out. We factor this difference of perfect squares into their conjugates. So for this one, we get x equals a negative 5 and a positive 5. So for this one, as we see it, 4 terms equal 0. We're going to factor by grouping. We factor out the x squared. We're left with this. Now, in order to get this, out of these last 2 terms, we have to factor out a negative 1, which reverses the signs. And now we have our common factor that we put here. bring this and that into another parenthesis. But now we have the difference of perfect squares that we factor into this, and all equals 0. So this will be a -1, this will be a +1, and this will be a -4. It's an equation to the third degree. We need 3 answers. Well, this will complete our review series of the additional exercises. From now on, we're going on to review for the final exam. And hopefully this series of little videos have been helpful, and that's their purpose. Don't forget, if you have questions, we want to answer them. And remember, anytime you spot a little error that might be in there, and I spot it every once in a while, record the time down at the bottom and get that bonus point. Bonus points help. Okay, well, good luck on your final and your final study and in your next course.